Hello, good evening, and welcome to Precision TV. Today we are going to be talking about something that's pretty interesting. It's the Molinere Project on the western side of Grenada. This project is pretty interesting and it's also very critical to the flow of traffic along the western side of the country. But it seems like from the inception of this project, there's so many things that have really dogged it from its inception. And personally, I knew that this was going to be something that was going to be challenging. And for that very reason, I sort of reached out to folks who were in some way had mentioned to me that they were connected to the relevant people involved in the project. And I did voice some concerns and, tried to give some sort of suggestions and clarifications of things that possibly could have gone wrong and the necessary due diligence that had to be taken to ensure a smooth running of a project of that nature. However, I did realize that the people that I was talking to really did not have the sort of connection that would have gotten the message to the relevant people connected to the project. And it was a little frustrating to see that everything that was said from the inception of the project that possibly could have gone wrong actually went wrong. And that's why at this juncture, where some progress has been made, I've decided that probably it might serve the best interests of the citizens of Grenada, just as a form of clarification and for their own edification. And I believe if there is any merit, if there is any value in what is being said, hopefully the message would get to the controlling authorities or the people who are, the stakeholders in this project. Also, the reason that I wanted to actually talk about this project at this juncture is also because I think it is at another critical stage. And it seems to me a lot of the civil stuff in terms of the grading and hopefully the drainage and the earthwork has been done. And things have stabilized to a certain extent. But right now we're entering a phase where a lot of the actual structural mechanism for the wall support and the road support would actually be put into place. So that is also very critical. And especially seeing so many of the issues that became apparent in the initial phase of the project, it's also pertinent, it's also very important that one should, really be careful about this aspect of the project. As I said, it's a structural part of the project, and that part is responsible for ensuring the safety of people who use the road. Of course, we're talking about vehicular traffic and the passengers therein. So there are a couple of observations that I wanted to make, and I pretty much want to divide them into three sections. And the first section has to do with the actual design of the project. The second part has to do with the personnel on the project. And the third part has to do with the management and execution of the project. So let's start talking a little bit about the design of the project. And as you would imagine, the design part of the project is very critical because the design documents or the contract documents are what the contractor uses to construct or erect this structure. So if these things are not clear, and if these things do not contain everything that is needed to give the contractor clear instructions in building this project, then there could be a major problem. And of course, as you would imagine, the personnel working on the project have to be technically aware of what the project is about and how to actually implement the contract documents. And of course, again, there's the aspect of the management of the project. The people who are managing the project, I'm sure, as you would imagine, would definitely have to know how this project should be managed properly. As for the design of the project, based on the things that I've seen that were done in the initial phases of the project, I am very suspect in terms of the sufficiency of the design, especially when I saw certain things like in the middle of a project while working on a project. I mean, there was a broken Nawasa pipe. There were situations where ministers had to actually come on television and warn, people that live in the area, like, hey, look, guys, you need to stay away from the project. You need to not pass through the area where work is being done. And there was actually warnings given to motorists. So to me, that in itself, from that observation, leads me to conclude that if you had a sufficiently designed project, these situations would not have occurred. And then just looking actually at the physical things that were done during the initial stages of the project, again, it was obvious that there were some deficiencies in the design. Then I also noticed, again, something that was very obvious is the fact that there was so much, what we say, turnover in terms of personnel on the project. Initially, there was a EIC, or engineer in charge, it seemed. After a few months, he was gone. Then we had some Cuban engineers providing some assistance. Apparently, I don't know what's going on. It seems that they're not there anymore. And then again, now we had, it seems like some other personnel. Like recently, the most recent I saw is someone that may have some sort of Trinidadian connection. Is pretty much giving some sort of directive on the project, and he was talking to the media concerning the project. So these sort of things, when you see there's so many turnovers in terms of personnel on a project, sort of gives you some clues as to things are not going pretty well, or at least was not going pretty well. So for example, let's talk about the design and the contract documents. And the things that I noticed, either the contractor didn't implement what was in the design. If it wasn't designed to begin with, then of course, then the contractor would be at fault. But if it was not in the design, it is something that should have been in the design. And on a fundamental level, let's talk about the design. The first thing that should have been done in this project would have been a proper survey of the particular area. And if the area was surveyed properly, one of the things you do, or one of the things that should be apparent in that survey, was the location of existing utilities. And if you were to note the location of existing utilities, and you saw some sort of conflict between the work that has to be done and its impact on the utilities that are in place, then the contract documents should definitely call for the relocation of those existing utilities, because you do not want the ongoing construction to affect the utilities, as was the case. Because apparently, while working on the project, we saw and we heard that Nawasa's pipe got broken because of the shifting of the soil, and of course that caused some problems for people in terms of water services and stuff like that. So again, if the design initially had that in place, where hey, you need to relocate the existing utilities so that ongoing construction would not affect or damage those existing utilities, then if that was not done, that would have been the contractor's fault. If it was not shown in the original design documents, then that would have been the designer's fault. And if it was not shown on the original design documents, then the client's representative, which in this case the client being the government of Grenada, the engineer in charge, would have or should have noticed that, hey, look, this sort of work may impact the existing utilities and something has to be done to rectify that. But apparently there's also word circulating that the original designers were not involved in actually the execution of the project, which sometimes also can be a problem, because if you had the initial designers, they can clarify things much more quickly to the contractor, as opposed to some new project management team being on site who is not entirely familiar with the drawings. And if there's some sort of redesign or some sort of alteration, it will be easier to facilitate that if you have the original designers some way involved in the execution of the project. I mean, that just really makes sense, right? While I go ahead, first and foremost, I want to say that the attempt in this video is in no way to put the spotlight in particular on any party or any company or anything like that. It's just to point out the things that went sideways and the things that didn't work. And I do understand, hopefully after having gone through this project, that the people who worked on the project would have gained a lot of experience, and for future cases, I'm sure they're not going to make the same mistakes. So I know we're always about parties, oh, this guy's probably an NBC guy, or he's probably an NMP guy. Well, I am apolitical when it comes to this video, so this is no way trying to say anything about any particular party. So let's just get that straight, before I continue. I wanted to get that out of the way. As I said, the sole value in this is to hopefully sort of give a little bit of information to the regular citizens so that they can understand what is involved in the project. And in some respect, they can also realize that it was not something that was very straightforward. It was not something that was very easy. There were challenges associated with it. And you really needed people who knew what they were doing to handle something of that nature. Also, I want to explain that the project was a project that, in some respects, I think the people who were working on it would not have been familiar with that type of system, retaining wall system. So, that is a system that's not extensively used locally. So that might have presented some challenges. And also, I wanted to make something clear that might have also caused some problems in terms of the personnel. So we're going to get to the personnel working on the project now. Now, I want you to understand, and this may be very apparent to some, and it may not be to others, but it's very critical when you're doing a project of that nature, where it's not as familiar as usually is the case. Hence the reason why you really need people who are very familiar with what they're doing in that type of project. And just like you wouldn't hire, let's say, a bone specialist or a surgeon to handle some gastroenterology problem that you may having, or you wouldn't get a cardiologist to do surgery. Well, it's the same thing with engineering. You wouldn't want to hire, let's say, a building structural guy to do a project of that nature. Neither would you want to handle, let's say, a transportation engineer to do a project of this nature. You see what I'm saying? So that could have been the problem. A guy comes along, or someone comes along and says, oh, I'm an engineer, or, I'm a Cuban engineer, or I'm a Trinidadian engineer. But for some reason, you have to gauge, first and foremost, what type of engineer that person is. Are they familiar? Are they suited to this particular project? And I want to just make it clear that a project of that nature requires specifically requires civil engineers, of course, for the grading, the drainage, the excavation. That sort of work is mainly falls under the category of civil engineering, general civil. Now, the actual structural part and the structure of the retaining wall falls more under an area of specialization, which is for geostructural engineers. So if you're not a geostructural engineer and you're a building engineer, this project is not for you. If you're a transportation guy, general transportation guy, or highway guy, specifically, this project is not entirely for you. Or you can have a role in it, but especially when it comes to the actual retaining structure being implemented, you specifically need guys who are, or gals, hey, we got to be politically correct now these days, right? So you need people who are specifically familiar with geostructural engineering. And of course, that is straightforward. Geo relating to Earth, structural relating to a safe structure that can actually take the loads that would be applied to it. And we're talking about loads in terms of pedestrians, we're talking about loads in terms of vehicular use, and of course self weight. So that's the personnel you want to have working on the project. And I could imagine that quite possibly, I don't know what you call it, if you call it the Ministry of Works or whatever you call it, or the guys probably may not have been familiar, again, with that new system. And the new system that was being proposed is what you call a mechanically stabilized earth system. Now, this is entirely different to a lot of the times in terms of retaining wall, what we are used to, which is more of a cantilevered, reinforced concrete retaining wall. Most people are familiar with that, especially most contractors locally would be familiar with that. But this mechanically stabilized earth system, being a little different, might be difficult for, guys who are, again, who are used to reinforced concrete retaining walls. And it's so funny, I'll tell you a story. Someone sent me a picture and saw all these excavation, and I guess they themselves, being accustomed to seeing forms and seeing, reinforcing bars and, for a typical cantilever system, called me and asked me, what the hell is going on? They got absolutely terrified. And I've also heard, there were people who were looking at all the excavation was taking place and what the hell is going on? Why is there so much excavation taking place? Because of course they didn't understand the new system that was in place. Just to get back a little to, as we're talking about excavation, just to get back a little to something that may not have been included in the design, and if it was not implemented by the contractors, and that is very critical, and that was what we call erosion control methods. And I'll break it down pretty straightforward. Now, when you have soil covered with vegetation, trees, whatever, grass, whatever, and you excavate, what you're doing is that you're exposing the soil to the elements of nature. Rainfall, water, whatever. So anytime you excavate or you disturb the soil, it is very important that you do something after you've disturbed the soil or you've excavated to protect the topsoil. And usually they're very, straightforward ways of doing that. As some people may be familiar with, you probably would plant some, some grass just to cover the soil temporarily. There's also a lot of polymers, or what do you call erosion control fabrics, which you will use to cover the soil temporarily because you've excavated and you've actually exposed it. So none of that was done. So that was a problem, okay? Because as you could imagine, now that you've removed the vegetation cover of the soil and you've excavated, what happens when a big rainfall comes down? That soil is exposed. You'll have erosion. So that was one of the things that definitely was not done. And if it was part of the contract documents, it should have been done by the contractors. If it was not part of the contract documents, that is very unfortunate. Should have been part of the design or should have been catered for. Another thing, again, that should have been straightforward had to do with what you would refer to as work zone traffic control. Work zone, of course, is the area that you work in. The traffic control means exactly what it says. You want to control the traffic. So instead of a minister, which is unfortunate because I don't think it's something that he had to do. It's something that the technocrats who understand and who's working under his command should have really understood, because I've seen a lot of that. I've seen which we would go through. I've seen the prime minister, you could actually see how much this project was kind of weighing heavy on him. And I understand, and it's sad because he didn't have to go through that. There are people being paid, technical guys who are being paid to actually do the groundwork, so to speak. And especially when you have to answer to the Grenadian people. and you have to face the media, and these guys are sometimes can be hostile. That's, that's a difficult situation to be in, which really he should not have to be in that situation, because hence the reason why you hire technical people to handle things like that. I mean, the prime minister and the ministers are, more or less directors of policy. They shouldn't have to be implementers of policy. You see what I'm saying? So that's where your technical guys come in, and the people who are actually doing the work. They're the ones should be responsible for things like that. So the work zone traffic control, that was not done. And there's a video, that we're going to take a look at shortly, where you would see that there was some sort of, sheets of galvanized across the street, at the beginning and end of the project. That's just something that you really should not be done. I mean, just think about it. Anyone can come, move the galvanized, and pretty much just drive in and put themselves in danger. So you want to, in situations like that, you want to have something that's more permanent, like a concrete barrier. And I could understand if you don't have, let's say, a preformed concrete barrier, and but this is something that's not too difficult. And the contractors themselves should have known you could actually just make some forms, create some rectangular concrete barriers, pour some cement in it, and you put it, 3 or 4 of these barriers across the entire street. So that is much more permanent and, harder to move. You see what I'm saying? And that would have, in many respects, solved all the problems of people trying to get through with their vehicle, and would have safeguarded them for their own benefit. So that is something that could have been done easily in terms of the work zone traffic control. I also saw another video where people were being warned that, hey, this is a dangerous site. You shouldn't be walking through the site. And again, that is something that I believe that the initial design should have involved, some sort of site safety, and a simple thing like surrounding the site with some chain link fence would have actually served the purpose of protecting the site and protecting people from getting hurt by coming on the site. And if you're talking about, I mean, I've heard numbers floated around about $20 million or whatever project. But anything that, you're doing above 10 million or whatever, I've heard numbers in the millions being floated for the overall cost of the project. And if you're doing something that is in the millions, it actually doesn't hurt, and, it would save you a lot of problems, in terms of people getting on the site and, a lot of things going really awry, so if you spend another 50,000, another 60,000 to just enclose the site, that would save you a lot in the long run. But obviously that was something that was not done. And thank goodness nobody got hurt, because there are people who could have gone on the site and seriously got hurt. One of the fundamental things that I also saw that was done is the means and methods used by the contractor. And I think this one should be really obvious. I think, the average layman who has no engineering knowledge or construction knowledge can look at this and say, well, this is something, if it was done, would have made sense. And I'm talking about in terms of the excavation. If you're excavating on a slope, I mean, it's just, basic common sense that at least you'll want to show the upper slope and support the upper slope in some way or the other. And there's several ways to do that before you start excavating on the lower part of the slope. I mean, that's just, something that really makes sense. And obviously that was not done. So then you have an excavation being done on the lower slope. And then all of a sudden, because the upper part of the slope was not showed or not supported, then that part of the slope also starts to cave in. So you're creating a lot of problems for yourself. So that was something that, I observed that really wasn't done. And, it's something that it's unfortunate to believe that the people who were actually doing this would not have thought about that. And it's even amazing, it goes back again to the design, the actual design phase of the project, right? The designers should in some way had incorporated some sort of shoring system for the upper part of the slope as part of the contract documents. And then if a contractor comes and he says, oh, look, This is not included yet. He definitely should have, sent a request for some information from, the original designers or the engineer in charge. And if the engineer in charge of the project comes in and sees that there is no shoring of the upper slope and you're going to excavate the lower slope, then he himself should say, wait, there's something wrong here. You know what I'm saying? So in terms of the technical ability and the technical aspects of the job, yeah, there were some, slip, and there were some lapses in terms of judgment. And again, as I said, it was a learning process, and hopefully going forward, these are some of the mistakes that would not be made. And as I said, it's very critical that these lapses in judgment do not take place in this particular phase of the project, because we're talking about, as I said previously, we're talking about the structural reinforcing system of the project, and this is very critical. This is the load bearing system of the project, and it's very, very important that they get this right. So we're going to take a look. We're going to start from the beginning and, take a look. It's always said that it's good to look back so that you can move ahead, not being stuck in the past, but at least we can, take a look at some of the things that should have been, spot on, but they weren't.
Slippage. The road has been closed since 2019, resulting in traffic being diverted through the Mount Morris community. The multi-million-dollar project has been undertaken by the St. Lucia-based firm Construction and Industrial Equipment Limited. On Monday, the GIs visited the site at Molinere with Avinash Dabade, CEI project head, and Aslam Sheikh, site manager. Avinash says currently CEI has projects ongoing in Antigua, Dominica, and St. Lucia, and the Molinere Land Slippage project is their first in Grenada.
For Molinere, this project government has intent to finance and do execute this project.
As you
Basically,
can see,
this is a missing link
you see the
for
entrance
the
to the
West
site
Corridor.
is actually blocked
And
by
currently, the
some
package what is awarded by the government to us is
some
from the channel 0
galvanized
to
and some pieces
630.
of wood.
And
That's
the
really not the
work
best
which
way to
is
do it.
involved in
Works
this
on traffic
project
control.
is extensive work for the excavation, demolition work, the piling, then backfilling, and the pavement part. So initially we are planning to do all the cleaners, general cleaners, and after that we'll do the demolition. And we are using the community people here. Local employment has been done, and we carrying out the cleaning activity right now. And after this phase get complete, we are starting the piling activity. And once it get done, then you will see the retaining wall construction, and after that is the pavement work. So these are the basic phases.
He says with the project commencing in the 2022 Atlantic hurricane season, his team has already strategized how they will handle the project to minimize any further slippage once the excavation work commences.
We can't, we have to work in systematic manner. This is more technical project. So as per our expertise and everything, we are confident to do this project on time with the quality and safety.
You mentioned piling, and so where are you getting these specialized piles from, and how soon can we see them on island, or are they already on island?
No, this piling
There
is
it
a
is,
long
the
lead
work
item,
zone traffic
and it is
control with
required
some
to import
galvanized
from other
blocking the
countries.
road.
It's coming
Definitely
from
not
the UK.
sufficient.
And this pile material has been ordered, as this project we got the awarded in last before 2 weeks. So we order the material, and most probably within next 2 months you will see the piling will be on the place. So where this new technology implement and hold ground in firm, and they are using the piling technology to hold the strata, and they are going up to the hard strata. So this as new technology will implement in such a way that you will get the fault line, it will encounter everything, and this all the challenges for the slope stabilization will be taken care.
CEI has been in the Caribbean for over 15 years, specialized in construction of bridges, roads, and handling of slippages.
Okay, so there we have it. That was the initial contractor on the job. I'm not sure where it's at right now. Haven't heard or seen that guy in a while. But you know, hopefully, probably they're still on the project. I don't know. I'm not jumping to any conclusions. But as you can see, that he was talking about how difficult the project possibly could be, and it's a new system, And of course, he was talking about the geogrids and the soil reinforcing system. So that was something, at least he gave everyone a heads up that this is it was a little bit challenging. But as you can see, and as we had mentioned earlier, and I pointed out, um, you definitely wanted to enclose the site, in terms of putting something a little more permanent, especially you would have been there for a few months, so that no traffic would actually venture further than a sheet of galvanized. I mean, that's definitely not something that's going to deter motorists from going into the area, or anyone, pedestrians at all, pedestrians or anyone trying to get into the work area. I mean, and that's just straight up, would have been dangerous for anyone to get into that particular area. But anyway, that was that. That was then. Then, I saw another update on the project.
Minister for Infrastructure and Physical Development, the Honorable Dennis Cornwall, says he is satisfied with the progress made on the Molinere land slippage project. The minister, along with Permanent Secretary Michael Stephen, visited the project site on Wednesday and met with the consultant and contractor to get an update.
So there you see. I mean, there was significant excavation being done, already done, but and this sort of gives you a better picture. As you can see, tons of this excavation has already been done, and there is no erosion control measures in place on these slopes. Again, as said earlier, if you disturb the soil, you have to do something to ensure that you protect the topsoil, and you can use some rolled erosion control fabric or membrane or something like that. And this is not something that's a significantly expensive thing to do. You see what I'm saying? So this is something that definitely should have been done on the lower slope, and at the same time on the upper slope. Upper slope should have been showed, and definitely the section and the areas where excavation was done, you wanted to definitely put some erosion control measures in place, and absolutely none of that was done. So I don't know, who didn't make that call, but that's a call that should have been made, and that would have prevented any further slippage, So unfortunately, that call wasn't made. So let's continue and hear what the minister has to say.
And met with the consultant, and 2022 is now at the stage where piles are being installed. Minister Cornwall says he is satisfied despite the inclement weather over the past couple of weeks.
So far, 100% of the piling has taken place. If you look in the video in the distance, you will realize that piling is still ongoing, and we do hope that the work continue to progress on a timely basis. We have had issues of abundance of rain, which has slowed down many projects on Grenada, but notwithstanding, we believe that this project.
So here it is. The minister talks about the amount of rain that they would have had while the project was taking place. And again, another reason you really wanted to do something in terms of erosion control. As again, for the life of me, I don't understand how no one would have saw that as necessary to be done. I mean, with all that rain, it's obvious if you don't cover the soil, then things can get washed away and could create much of a bigger problem, which actually did happen.
Project is still on track and should be able to finish within the 10-month period as we have indicated initially.
Minister Cornwall also used the opportunity to remind residents of Molinere and surrounding areas on the dangers of using the project site as an avenue to get from one point to the other.
As the work progresses, it is becoming more and more risky for them to traverse this area. In my initial meeting, I did tell you that there would be challenges, there would be need for patience. And we do not want you to continue traversing this area. It's dangerous for your own good. So I'm pleading again to do not attempt to pass while work is going on. The contractor would stop for a very short period to allow them to basically get into the January month. Notwithstanding, it's not a sightseeing scenario. We're asking you to refrain from crossing the area because the site is still very unstable.
And there it is, and absolutely agree with him. And the thing about it, someone, should have seen again. It's he's not the one managing the project, so the project managers or the engineers in charge, who should have been the ears and eyes of the client, which is the government, should have saw, it fit and should have said, you know what, it's hard and it's difficult to control people, especially people living in the area. The only way that you're gonna stop them is that you have to put some sort of physical barrier between the site and the surrounding areas. And again, as I said earlier, if you're talking about millions, it would have been worth it to spend, 50, $60,000, with some chain link fence and surround the site, and you would have prevented all of that problem. And luckily, as I said, no one got hurt, but this is something that could have caused, major, destruction, and somebody could have gotten hurt.
The pipeline would become a problem. We need to basically remove that main line that is running on the top here. It has to be removed to allow for the construction of the road to take place. Further excavation will be taking place, and the pipeline would become a problem or a stumbling block in our way here.
So there it is. And this is something that, again, we talked about it earlier, where a proper survey of the site would have taken into consideration existing utilities, and the actual extent of the work zone would have been considered. And this is something that should have been done before relocation of utilities, should have been done before the actual initiation of the project. And there it is. And the problem is that if you get these things done before you start the project, then guess what? There's no interruption, and you can have a smooth flow, during actual construction. Now, imagine in the middle of the project, someone realized that, hey, you know what? This pipe is going to get in the way, and we need to relocate it now. It's crazy. I'm sure that someone would have known that there's an existing utility there. You know what I'm saying? So again, the designers, this is something that they should have considered, and obviously they didn't. So time and money would have been wasted trying to relocate that pipe in the middle of the project. You guys would have been down for a couple of days. So you understand, you know how it goes.
Piling, and next time is after the piling, we reach up to the required level, and after that we are going ahead with doing the blinding and the pile cap foundation. So within a couple of weeks you will see that pile cap foundation will get it done, and then the next level is the structural back.
Okay, well, let's get a little bit of the structural backfill. All right, so there we go, and he's talking about the piling, and basically that piling in some respects is used for the face of the retaining wall. And the reason being is that you need a very stable foundation for the face of the wall. Usually, had it been a different situation, you might just have a spread footing to build your wall upon. But in this case, because of concerns in terms of the soil strength, they would have used some piling to give you that little additional strength and a better foundation for the face of the wall. And then you heard him talk about the backfilling and stuff like that. And soon I will, show you a picture of the actual system, so you'll get a better idea of what the actual system looks like.
There seems to be no ongoing work at the Molinere Slippage Project. Heavy equipment is on standstill and no workers on site.
So there we go. Obviously, some of the problems that became apparent and took place. The previous video was like 11 months ago, and this was an update apparently 2 months ago. So obviously there was some stoppage there. There was need for redesign. There was need to stabilize the upper slope. And as you can see in the background of the lady that's giving the news, the journalist, you can see that what had to be done is some sort of stabilization of the upper slope. So something that should have been done first had to be done in the middle of the project, And as you can imagine, that would have been, slowdown in work and lost time and lost money. You know what I'm saying? So these are some of the things that ends up happening when things are not planned properly. The good thing about it, eventually they figured that they had to bench the upper slope, which is exactly what is being done. So what you're seeing in the background is that the upper slope is being benched as to stabilize the upper slope so that work can continue on the lower slope where the actual retaining wall and roadway will be going. Let's take a look at this video again and hear what the lady has to say.
So why is the project on halt? We spoke to Minister for Mobilization Andy Williams for an answer.
The first design we had from for the Molinere project, it did not take into consideration the top of the hill that's by the road. So what happened is that some months ago, one of the water lines, the major water line burst, and the water went, it sprayed on top, and it has some of the debris coming down in full. So, but besides from that, you have debris coming down from time to time. Now, the second design that we are doing, that have just been completed, it took into consideration the debris coming down from on top. So basically, we had to redesign the whole project, and because of this, the project had to be halted for the time.
So imagine, there it is. Imagine you paying designers to do a project, right? And the designers pretty much designed the project, without consideration for major aspects of the project. It's pretty interesting that will be the case. It's just amazing. And there you can see the pressure's on. I'm sure the community and people at large were concerned about what is going on. And in some respects, you could have seen the minister being put in a very uncomfortable situation, which really, in some respects, it's not really his fault. And again, you would think that he would have been relying upon people with the technical ability to ensure that he is not put in this sort of situation. And that was unfortunate that he had to be put in that sort of situation. He had to, scurry for answers to try to say, well, look, we had to do a redesign again. So what does that involve? A redesign involves more money to redesign. Then you had guys sitting on the project. Time is being wasted. You're not talking about cost and money loss in terms of you're not able to use the site. So, it's again another unfortunate situation. And of course, we talked about the utility not being relocated before the start of the project. Again, we had a situation where the pipe burst, and that in itself caused even further detrimental consequences.
The minister further explained that the new design is now complete and work will soon commence on the project.
So the redesign is finished, and part of the redesign had to do with adding more piles to the road. So the piles are on the port now. We cleared some already, and we are in the process of clearing the others. When the pile is when we have completed clearing the piles, then you can look at work being started on the road. But basically, we had to do that because, if we had went with the first design, it would not have been proper. And we wanted to do a proper work on the Molinere Road so that we do not have to go back there again, to...
So hopefully, if this design was not proper, as the minister says, in some respects, the original designers will have some culpability for not providing us with a proper design. And hopefully they can look into some sort of recourse.
Anything. So right now we are confident that the engineers who redesigned the project did a proper job, and in my opinion, it's a better design than the first one.
Williams said the project will be completed in January 2024.
Engineers from all over Grenada to look at the plan to really give their view on it, and they were satisfied with the new design that we have. So
well, again, as we said, it's not just getting engineers, to look at the project. You have to get the right engineers to look at the project. And again, it's important that we understand that if you're going to have engineers look at a project, they have to be general civil for the excavation stuff, and they have to be geostructural for the retaining wall, which is the most critical part of the structure.
Are aiming to complete the project in Molinere in January coming. It costs
in the constituency at the moment. And to me, I find it's a hiccup to the people who live on the northwest side.
Well, you hear a lot of different things from people, but my personal view is just that things just moving a little.
Speaking at a press brief on Tuesday, Prime Minister Dickon Mitchell underscored the critical importance of addressing the Molinere landslip.
Well, the Molinere project is and when you say Molinere, we talk about the landslip, yes? Right, so the landslip is a very distinct project, because if we don't fix the Molinere landslip and get a road, effectively there's no western main road, there's no western corridor. You're either going to have to go through Mount Parnassus at Mount Marks that we're currently going, which is dangerous and really only meant for one-way traffic. That's not sustainable. Or you can go through the bypass that we recently built, which is Mount Kuma, which is obviously significantly longer, and also has some disadvantages because people living close to the Molinere area obviously then don't have bus access. So we committed to solving the Molinere landslip, because if you don't have that, you literally cannot do anything in terms of improvement to the western main road.
And there you have it. I mean, again, you can just imagine how frustrating it might have been for the Prime Minister. And I can just imagine the situation that he would have been in. I mean, you can see physically how he responded to the questions being asked. And, you know, it's a sort of thing that, oh my goodness, do I have to really deal with this again? You know what I'm saying? And that is something, that is a situation where he should not have to be in. Again, as we said, you know, the ministers and the Prime Minister should be directors of policy and not implementers of policy, and not have to answer so much of all these technical questions. This is something that should have been referred to, let's say, the guys in the Ministry of Works. I mean, the engineers in charge. They, you know, would have been in a better position to answer the questions. And it's unfortunate that the Prime Minister had to be put in such a difficult situation, and really he should not have been. But hey, as I said, hopefully all these things that were done or weren't done would be seen as some sort of learning experience that would not be repeated. So now what I'm going to do, I'm going to get into a little technical, and I will keep it as simple as possible, aspect of what the project, in terms of the actual structural part of the project, what is involved and what is being done, especially now that they're actually going to start building the retaining wall. So we're going to take a look, use some schematics, and that will give you a little insight as to what exactly has to be done. Okay, so there it is. What we have on the screen is pretty much very similar to the project that is being done at Molinere, and fundamentally represents a typical mechanically stabilized earth retaining system. And as you can see, fundamentally consists of a leveling pad with a concrete facing unit, and you might have heard the original contractor talk about the geogrid. So these geogrid extend back from the face of the wall, right? And there's many different types of connection mechanism for the geogrid to the face of the wall, and sometimes they can use steel strips or some sort of ladder type saw reinforcement system. A lot of these things are either metal strips or they're polymers, really hard plastics set up in a solder grid. But as was said by the original contractor, it seems they're using a geogrid. So I would also show you what a geogrid looks like shortly. But basically, this is a soil reinforced system. So the soil is reinforced by these geogrids, and usually every 18 inches between geogrids. So you'll have the first geogrid, right? And then on top of that, you'll have what you call some sort of select structural fill, or some sort of select fill, which is really good fill that's drainable, and which is really good fill that's drainable, because you don't want to just put any soil at the back of the wall. You want to make sure they have something that's the proper fill and it's drainable. It's not going to retain water and stuff like that. And you would compact these every 18 inches. So you will compact this level, all right? Then you'll put in another roll of geogrid. Then you'll compact for another 18 inches, another roll of geogrid, and pretty much that's how the system works. I mean, you can imagine, like, if you just have soil, it would not be as strong. And you can think of it, if you put some straw in between the soil and you compact it, then you have a stronger system that would be able to retain the soil behind the retaining wall. And then we're not sure what sort of system they're going to use for the wall top out. Sometimes they have many different types of system. You can top out a wall. They can have a cast in place parapet wall. Or, as I said, there are many different types of way of finishing the wall. It depends on what the design calls for. But here, what is being shown is like a precast top-out wall, top-out system that you can put in place, and then you have the roadway. So what I want you to imagine this system. This is, it's easy to understand if you think about it. So let's say you have a vehicle that's traveling above on the roadway. This is the roadway. And you can only imagine that vehicle would have some sort of weight that's going to be pressing the soil downwards. Pressing the soil downwards. And as a result, because the soil is being pressed downwards, what would it try to do? It would try to expand laterally, right? It's going to try to expand laterally. But what keeps it in place? And as you can imagine, in this system, in this particular system, what keeps it in place is that there's some sort of friction between the geogrid and the soil, and especially when it's compacted, that makes that friction, work much better, right? So that is the resistance system that's going to prevent this soil from moving laterally. And that's the beauty of the system. So you don't have to worry about building a whole set of forms and create some sort of cantilevered retaining wall system. It omits all the formwork, and it omits all the rebars and stuff like that. The good thing about it, usually, I'm not sure that is the case in this particular project, but usually these facing units, they're much thinner in this system, and they're usually what you call precast, meaning that they're already made, and you just put them in place, and there's a lot of little nuances and mechanisms to put them together, depending on the type of facing unit that you use. Sometimes even for this facing unit, you can use a block wall. There are many different types of systems, but this is a general, typical system. This is a cross section through the road that's going to be in Molinere. All right, so this is the sort of system that is being used. And as I said, this, it might be a new sort of system that is used locally. I don't know if it was done before. Probably might have been done before. But if it was not done, I could see it being a little challenging to have and do it for the first time. But hey, everybody who's involved will learn. And as I said, for the next project, it should be a breeze. And the thing about it, when something is difficult, you see all the problems that can occur. And hopefully, again, for another project, you're going to remember. It's sort of like mental training. You're going to remember all the things that went wrong, and then you can anticipate the things that went wrong, and you can prepare, and you will be better able to take care of these problems when they occur. So, hey, learning is difficult sometimes. And there's an old, saying that it pays to learn. It's difficult to learn. You have to go through. You gotta, knock yourself a bit, and then when you really learn it by your own hands and own experience, then again, you're not gonna make the same mistakes. Hopefully. And here, this is the contrast, and this is something probably that most contractors locally would have been familiar with. So here you have what you would call a cantilevered reinforced concrete retaining wall. So usually in this wall system, you'll have a bunch of rebars, and you'll have a bunch of rebars in the footing of the system. So this is a sort of system that most contractors locally might have been accustomed to. So I could imagine it being a little intimidating when for the first time they would have seen a more of a mechanically stabilized earth system, which is entirely different, and that would have afford a little bit of challenge. So with the mechanically stabilized earth system, and pretty much the same with the cantilevered system, usually the length of these straps are about 80% the height of the wall. So it's about 80%, and that is usually sufficient to ensure that at minimum 80%. And of course, a lot of that depends on the sort of loading conditions in terms of vehicular traffic and what is expected on the roadway. So, but as a rule of thumb, it's usually 80% the height of the wall. So I'm sure all of this would have been taken into consideration. So as I said, I wanted to make this video so at least the average citizen could understand what is actually taking place, and hopefully would see some sort of light at the end of the tunnel. And when they see the project is going through different phases, then they would understand exactly what's taking place, and there'll be no surprises. One of the concerns that I'm sure this is something that they might have considered, though, is that yes, the upper slope was benched, but we have to think about what's happening at the edges of those benches. So it's quite possible they might be doing some sort of staggered wall, or some way for retaining the sides of the benches. That's a whole different thing. Hopefully they'll take a look at that, and they'll figure out how to do that, because there's also some houses that are adjacent to the sides of the bench, and hopefully you don't want those to be affected. So there should be some sort of containment at the sides of the benches, and possibly they'll look into that. I'm sure they will. So one last thing before we sort of wrap this up. This is what the geogrid looks like. Some of them are rectangles, some of them are shaped like this, but it usually comes in rolls, so it's very convenient and easy. When you have the first level, you roll it out, and then you cut and you overlap, based on the width of the geotextile. Some of them come in 20 feet, whatever. But I'm sure the guys who are installing it will be familiar with the process. But this is what the geogrid, and as I said, they're made of like polymers, really hard plastics, extremely hard plastics that serve as the reinforcing system in the soil. So there you have it. And that's what we're talking about when we're talking about the Molinere project. Hopefully, I hope this video was informative and would have clarified a lot of things that you might have been concerned about. And as time goes by, if there's a need to sort of update something, or make another video concerning this, then I sure will. But for now, I think this is sufficient in terms of creating a little bit of clarity. So this is Precision TV, and I'm signing off. And you take care of yourselves and have no fear. I'm sure eventually they'll get it together. It'll be all or nothing, but hopefully this will turn out to be a good design and a good project. We'll see what happens. Take care, guys.